Assalamu alaikum everyone. Today I'm going to provide information about the polysynaptic FLEXOR reflexes as possible as. Please first of all look at this illustration. I draw this illustration for memorizing easily and understanding easily. First of all, look at this. The broken glass can hurt the foot of this person, and this first of all, I should say that this is under the this is the bottom of the river, maybe river or some kind of water resources, and the person couldn't see this broken glass. And when the person put his foot on the glass, broken glass, this person sensed some kind of painful sensation. The receptors generate action potential and collect information about the stimulus via the pseudonephroid cells, and the pseudonephroid cells' second fibers carry information to the spinal cord and synapse various other cells. First of all, look at that. The plus is stimulating, minus is inhibiting the fibers. Plus, first of all, the plus fibers innervate the flexors of the leg, and the inhibitory fibers is responsible for the extensors of this leg. Look at that. If the lateral flexors have to contract, there is some kind of point. When the ipsilateral flexors contract, the leg may be moved from the painful stimulus. It's beneficial for everyone. It's some kind of protective response. And without inhibiting the flexor extensors, we couldn't contract the flexors. Okay, there is some kind of planet action. The second one is contralateral side of this leg, and that's left leg and that's the right leg. For maintaining our posture in stable position, we have to contract the extensor of the another leg. Get that? The right leg, the plus is stimulating the extensors and the inhibition of the extensors. Okay? It can facilitate us to avoid from the painful stimulus. That's a quite simple example of the polysynaptic FLEXOR reflexes. In addition to this kind of synapses, there is another fibers that ascend to the cerebellum, brainstem, and hemispheres. And all of the information I provided about this unintentionally. What I'm going to say is that without wanting this kind of action, we can act like that. Without any planned action, okay? But some kind of emotional responses, crying maybe, and using your hands to hold the painful part of your body, it is the willing actions, and it can be caused by these structures of the nervous system. The next information about the regulative circuits of the muscle length and tension. It's quite difficult, but if you listen and watch carefully, you can understand easily without any difficulty. Okay? There is most important receptors available inside of the muscles. That's muscle spindles. Muscle spindles generate action potential, and this action potential carried via 1A fibers, and these fibers connected with alpha motor neurons. And as a result of motor neurons cause the contraction of this muscle. When and how can we activate muscle spindles? As a neuropathologist, you can activate these muscle spindles by beating this tendon of this muscle with your hammer and something like that. And there is an important point, there is gamma-1 fibers. Gamma-1 fibers is responsible for static posture of our body. You know, the static posture means that we are holding your body in the same position, like that and like that. Maybe 1 minute, 5 minutes, or 10 minutes. And look at that. The gamma 1 fibers innervated by central input from the central nervous system, maybe hemispheres or brainstem, something like that, and they can regulate the gamma 1 fibers. Gamma 1 fibers, as a result, cause some contraction the of the fibers that are located around the muscle spindle. Contraction of this kind of filaments cause the activation of the muscle spindles. Muscle spindles provide information about the stimulus, and 1A fibers carries information, and 1A fibers connect with the alpha motor neurons. Alpha motor neurons cause the contraction of this muscle, and we can hold our posture in the same position, like that and like that. Next information about the regulated sequence of muscle tension, and it's a little bit difficult than this illustration. Listen carefully. Golgi tendon organ, you have heard about that. Golgi tendon organ is responsible for detecting and analyzing the tension of the muscle. When the stimulus or the muscle tension is enough for causing and activating Golgi tendon organ generate action potential, and it can carry these impulses via 1B fibers. And 1B fibers can connect another neurons, and as a result, contraction of this muscle via alpha 2 fibers can happen. Look at there, there's two fibers. Two fibers have another different function if you compare with this kind of fibers. Two fibers carry the information about the contraction of this muscle to the antigenous muscles. When these kind of muscles started contracting, two fibers activated and carry the information to the antigenous muscles and cause the relaxation of the antigenous muscles. And there is gamma 2 fibers. Gamma 2 fibers is responsible for our dynamic action. You know the dynamic action examples, for example, running, swimming, cooking, something like that. Maybe breathing in and breathing out, and like that. You know the gamma 2 fibers innervated by pyramidal tracts. You know the pyramidal tracts Pyramidal tract starts from the best cells that located in the placentral gears that's responsible for our actions. Okay? When the pyramidal cells the gamma 2 fibers activate, gamma 2 fibers activate some kind of filaments there, and when these filaments contract, the muscle spins become activated. You can ask me some kind of question. What's the difference between the gamma 1 fibers and gamma 2 fibers? And the gamma 2 fibers cause the overactivity of the muscle spindles. As a result, muscle spindles carry higher density information to the spinal cord, and the spinal cord analyzes it, and this information carried to alpha 2 fibers, and the muscles become contract strongly than this reaction. Okay? For that reason, we can act some kind of our dynamic actions, running, swimming, and something like that. All of the information today I was going to provide you is all. Thanks for listening and watching. Once I'm going to talk about that nothing is perfect. That's merely second lesson, my video lesson. And now that there are so many grammatical and some kind of pronunciation errors, in our previous lesson I wrote down my nickname in the Telegram, and if you notice some kind of errors, grammatical pronunciation errors, please write down me, and step by step, next lesson I'm going to correct it. And my first aim is organizing some kind of complex resource that related to neuroscience for not only with medical students and for international students. Thanks for listening and watching once more time.